All right, so we're going to talk about solving equations with variables on both sides of inequality. And at this point, what you need to understand about equalities is equalities simply state that one side and the other side are literally the same amount, even though they may look different. So for instance, we've got this 5x plus 3 over here, and we're saying it's equal to 7x minus 11. So while they're not written the same, what you need to understand is that we are the same, and they are identical in value. So what we need to find is the 1x that I can plug here and plug here that will end up making this entire quantity and this quantity equivalent to each other. So we're just going to talk about the process to do that. So process to do so. So one of the most important things we need to understand is that there's this simple little thing, okay? The first thing on any type of expression or any type of equation that we always want to do is we want to do something called combine like terms. And if we notice, we have a 5x and we have a 7x here, right? We also have a positive 3 and a negative 3. These are my like terms, right? And what we've got going on is that in no matter what expression we have, we always want to combine like terms. And it doesn't matter how you combine these like terms, but generally speaking, while we're combining like terms, we also simultaneously want to be thinking about isolating a variable at the end. So notice that if I bring this 7x and combine it with this 5x, and we'll talk about how you do that in a second, but if I take this 7x and I'm going to simply combine it with the 5x, okay, we want to then talk about why I don't want to bring this negative 11 and combine it with the 3, okay, simply because, remember, we want to combine like terms while simultaneously trying to isolate a variable. So if I'm going to bring my variables when isolating them and combining them to the left, I then want to simultaneously take my number, if it has a partner to combine with, and move it over to the right, okay? So what we kind of have here for the beginning start of these equations is we'll always kind of have this idea of something going left and then the opposite thing going to the right, okay? So now, what's important is that we can't just say, oh, well, let's just take the 5x and the 7x and make it a 12x. That is not allowed, okay? So the other rule we need to follow very quickly is that if I move an entire term, okay, so 7x is the entire term, right? Or if I were to move the 5x, it doesn't matter. What we need to have is that when we move across an equality sign, it becomes the plus minus. So what that means is that if something was once plus, as it travels across the equal sign, it becomes the negative, all right? And the way that you've shown these steps in the past is that you've done minus 7x, okay, or plus 3 or whatever it is. So I'm going to do minus 7x minus 7x, okay? So then I get my next step, all right? And what I have is now 5 minus 7x, and on the right-hand side I have, okay, I've got 7x minus 7x, which is just going to be 0, and I'm a big fan that if something equals 0, I put a strike through it, all right? So 5x minus 7x is negative 2x. Don't forget on this side I still have the positive 3. And that is going to be equivalent to the negative 11 that still exists over here, all right? So now again, we still have like terms to combine, and the like terms that we have to combine are what I talked about before here, are this positive 3, okay, and this negative 11. So we still need to combine them, right? So the way we combine them, again, we just need to keep in mind that if I move across a equal sign, that this plus minus thing has to happen. So if it was once positive, it needs to become negative. So we continue on. So I go minus 3, and then I'm left with my final answer so far. Next step is going to be negative 2x is now equivalent to negative 14. Okay? So now the problem is that I don't want to know what negative 2x's are. I want to know what just 1x is. Okay? So now I don't want to move this whole term over here. All right? So I don't want to move this whole negative 2x term, okay? I only want to get rid of the negative 2. Well, the way you get rid of the negative 2 is if you have multiplication, right? We want to turn it into a 1, all right? So we need to turn that into a 1. What is the quickest, easiest way to turn anything into 1? And that's to divide by itself. So what we go ahead and do is we divide both sides by negative 2. And because I'm in an inequality, when I divide one side, I must divide the other side. So negative 2. And then I calculate my values. I do not now, in this case, cross this out. Okay, what I'm going to be left with here, all right, is that this is a big 1. So I draw a big 1 through them, and what I'm left with is 1x is equivalent to negative 14 divided by negative 2, which is positive 7. So my final answer is x is equivalent to 7. So let's try one more of those. So again, here's another problem, and we're going to go through the same process, okay? So we want to combine our like terms, and our like terms that we want to combine here are going to be the negative 3x, okay, and this 2x. And we also then have this positive 6 and this positive 4. So these are our like terms. We still need to combine them. It does not matter which side you move which to. Just remember, we want to simultaneously combine like terms while trying to isolate a variable. So what I'm going to decide to do, okay, just to show you, is I'm going to move my x's this way, and I'm going to move my numbers that way, okay? So my x's are going this way, and my numbers, I'm just going to use the pound sign, are going to go to the left, okay? So the way I'm going to show that now, if I want to move my x over to the right, remember, I am definitely going to be crossing over or passing through a equal sign. So negative 3x needs to become positive 3x. So I add 3x to both sides. On this side, I'm left with 0. I cross that out. And now when I write this up for my next step, I get 6 is equivalent to, so 2 plus 3 is 5x. And I still have that positive 4 there. So again, I'm still keeping in my mind that my numbers are going to go to the left. So what I had that right here, okay, numbers are going to go to the left. So I'm still going to take this positive 4 and I'm going to move it over here. Now remember, this positive 4, as it goes to the 6, it passes this equal sign. So to get to that 6, I have to be thinking about minusing a 4, okay, minusing a 4. And what I'm now left with here is a 2 is now equivalent to 5x. So the next thing I want to do is I want to get it to being just 1x. Well, again, we talked about this before. What is the quickest possible way to make something 1? And that is to actually divide. So what I'm going to do here now is I'm going to divide both sides by 5, divide by 5, and I'm going to be left with my final answer of x being equivalent to, so this is 1x, so 1x is equal to 2 divided by 5. This is a fraction, so you can leave it as 2/5. You do not always have to divide the fraction out to make it into the decimal. You can just simply leave it as 2/5. And there you go. That's the process for solving when you do these problems for an introductory.